Okay, so I'm going to make the review for the Chapter 9 or Unit 9 test. Question 1 through 11 says, identify each chemical reaction as synthesis, which can also be combination or addition, decomposition, single replacement, double replacement, or combustion. So when I did it, I said, well, I know that these two are going to come together. SO2, sulfur dioxide, is going to come together with oxygen to make sulfur trioxide, so I call that a synthesis. If you don't like the word synthesis, you can use addition or combination or composition. Those are all valid terms. This one, the aluminum goes and partners with the hydroxide. The calcium goes and partners with the sulfate. So basically, aluminum and calcium get new partners, so that's a double replacement. And I allow my students to simply put DR for double replacement. Now I want to look at the one right underneath it. Anytime I see oxygen, I immediately have to say to myself, well, is it with a hydrocarbon? Hydrocarbon. There's your hydrogen, there's your carbon, so yes, it is. So that is combustion. But I make them write that word out because someone could be using it as combination, so you have to be careful. You can't put the C, it needs to be combustion. This magnesium is going to replace that silver, and then this silver is going to be by itself. So I call that a single replacement. And I let my students call that an SR. All right. And then I go on to number 5. Barium is going to pair up with the phosphate group. The hydrogen is going to pair up with the nitrate group, so I call that a double replacement. Number 6, the magnesium is going to break down into, this was magnesium chlorate, it's going to break down into magnesium chloride and oxygen, so that one is a decomposition. This beryllium is going to meet with this oxygen and make beryllium oxide, so I know that's a synthesis or an addition or a combination. Synthesis, all right. And then I'm going to move on. I'm going to look at number 7. I just did, sorry. Number 8 is where I should be next. I'm going to change that ink color. I want aluminum to kick the carbon out and pair up with the sulfate, and there's the carbon by itself now, so that's a single replacement. This lead oxide is going to break down into lead oxide and oxygen, so that's a decomposition. This is a hydrocarbon. In the presence of oxygen, it will burn and give us CO2 and water, and you always get that with a combustion reaction. And then sodium bromide plus iodine. My bromine is going to get kicked out by my iodine, so those are basically going to swap places. So if that happens, I know that I have a single replacement. So that took you through 1 through 11. All right, let's move on down. I'm going to go to 12. Okay, 12 says, complete the chemical equations for the following synthesis or combination reactions. Use swap and drop. So MgO. This is a +2 and a -2. So that adds up to 0. I don't have to swap and drop, but I do need to balance the reaction. So I'm going to put a 2 there and a 2 there. Calcium plus sulfur gives me calcium sulfide. That needs to look more like a capital S. +2, -2, no need to swap and drop. It's balanced. It looks really nice, so I'm going to rewrite it. Calcium sulfide. All right, and then I had sodium plus oxygen, and that gave me Na2O. Now, where did that 2 come from? Well, this is a +1 and a -2, so I did a swap and drop because it did not add up to 0, so I had to. It is not balanced, however, so I'm going to put a 2 there and a 4 there. Sodium plus chlorine is going to give me NaCl. +1, -1, no need to swap and drop because that adds up to 0. I need to realize that I have 2 chlorines, so that causes a 2 to go there, but then that makes me have 2 sodium, so I need a 2 there. Aluminum plus oxygen gives me aluminum oxide. Aluminum is +3. Oxygen is -2. I definitely have to swap and drop, so that 2 goes down to here, that 3 goes there. This gets rid of. I'm erasing that. It is not balanced, so I'm going to put a 2 here, a 3 here, and a 4 here. So that tells me 2 times 2 is 4 aluminum. That's why I needed a 4. 2 times 3 is 6 oxygen, so that gives me 6 oxygens, and everything looks like it's in good shape. All right, so I'm going to move on down to number 17. Okay, number 17 says to use the activity series of the metals to complete the following single replacement reactions. This is located in your notes over over reaction types. It was the very first set of notes we did. It's on the back of the first page. The back of the first page. So if you want to pause and get that, that would be a good idea. And what you're looking for is you're looking for which of the two metals is the more active. So on 17, my choices are zinc and silver. Is zinc more active than silver? Yes, it definitely is. If you find silver on the activity series, it's way down below. So the zinc is going to combine with the nitrate, and silver is going to be by itself. But I have to go back over here. Zinc is +2. Nitrate group is -1. If you don't know this group, it's on your list of polyatomic ions. So I'm going to have to do a swap and drop. The -1 and the +2 do not add up to 0. So that becomes zinc nitrate. Notice I have 2 nitrate groups, so I need a 2 out here. That makes me have 2 silver, so I need a 2 there. Gold is so lazy, it's very, very low on the activity series that no reaction will occur because it is a lot less active than potassium. It will do no good to try to react it with potassium nitrate. Aluminum and sulfuric H2SO4, sulfuric acid. You have to look and see if aluminum is going to kick the hydrogen out of the acid, and it will. So then I get aluminum sulfate, +3 for aluminum. Sulfate is a polyatomic ion. It's a -2. So I do a swap and drop. So I'm going to rewrite that as Al2, SO4, 3. And then this hydrogen is all by itself. Remember, when it's by itself, it's diatomic. So I'm going to write it as H2. It is not balanced. It looks like I have 3 sulfate groups here. I need a 3 here. That gives me 6 hydrogens, so I need a 3 here. I have 2 aluminum, so I need a 2 there. Now it's balanced. And life goes on and looks quite lovely. Copper and water. Copper is not strong enough to kick the hydrogen out of the water. That only happens if you are, I think it's from lithium to sodium on that activity series. So look at in your notes and make sure. So no reaction will occur there. Aluminum is more reactive than copper, so it's going to kick the copper out. And I'm going to get Al2, parentheses SO4, close parentheses 3. And then I'm going to have copper by itself. It is not balanced, I don't think, so I'm going to look at it and see if I can balance it. 3 sulfates, 3 sulfates. That changes that to 3 coppers. 2 aluminums here, 2 there. I believe this should be lithium. So I'm going to react lithium with hydrogen. Lithium is very reactive. So lithium, remember that water is made up of an H group and an OH group. So lithium is positive. It likes that negative OH. So I have lithium hydroxide, +1, -1. And then this hydrogen is left by itself, so I need to write that as just H2. Now, it's not balanced, so I'm going to come back and erase some of this. I have a lot less messiness to work with, and we'll rework that one. Okay, so we said this was just plain old lithium, so I got lithium hydroxide, +1 and -1, and then this HOH is a good way to think of water. So I put the OH with the lithium, leaving me the hydrogen alone. Hydrogen by itself has to be written as H2. So I'm going to get rid of that. I'm going to get rid of this because I didn't need to do a swap and drop. Now I'm going to check it. I have 2 hydrogens, but here I have 3, so that's not good. I'm going to put a 2 there and a 2 there. And that gives me 2 oxygens, so I need a 2 here. 4 hydrogens, 2 and 2, 2 here, and 2 here is 4, so it's balanced. Okay, now I want to react carbon 8 H18, which is octane with oxygen because it's a combustion reaction. I know since it's combustion that I must get CO2 and H2O. So I balanced it. I played with it for a very long time, and when I did, I realized that I needed a 2 here and a 16 here, because that was 8 times 2 is 16 carbons and 16 carbons. H is next. 2 times 18 is 36, so I needed an 18 here. And then I checked out my oxygens. This was 32 oxygens. 16 times 2 is 32. And then I had 18 more oxygens from this situation here, so that was 50 oxygens, so I needed 25 right there. When you balance these combustions, do it in the order of CHO, or do it alphabetically. That's the same thing. Do carbon, then hydrogen, and save your oxygen for the last. All right, my next one is C6H12O6 plus some oxygen. Gives me CO2 and H2O. Combustion always has products of carbon dioxide and water. 6 carbons here, 6 here. 12 hydrogens here. 6 oxygens and then some here. I know that I have 12 oxygens here and 6 more here, so I have 18 oxygens. I have 6 here. 18 minus 6 tells me I need 12 more, so I'm going to put a 6 right there, and it's completely balanced. Erase that and move on. Okay. This one you have to use the chart that's on the very back of your first set of notes. It's the solubility chart. Be careful with that one. It's a little confusing to read. I'm going to stop this recording and post it, and then I'll start with number 25.